Hey everybody, I am meteorologist Jim Rinaldi, and going to take a look here at what's going on with this storm here and explain some things that could be happening with it as we go forward in time. First of all, I want to show you here the loop here and things that are going to be happening and what's actually happening now. I'll show you the water vapor loop in a second here, but first of all, let's take a look at this loop here. This is the NAM model 500 millibar height field, and watch what happens here. Watch this short wave here, this energy here. That trough is going to be negatively tilted. Watch it come down here. We're going here and we're coming across, and watch to see it's going negatively tilted here. That's a negatively tilted trough. That means energy. It means a developing storm system, a strengthening storm system. Now, watch what happens with the heights as that happens. Watch the heights as this trough comes here. Watch, we're southwest here. But as that trough starts tilting negatively, those heights back to almost due south by the time we get to this point here. And I'll show you that here in a still picture. Let's stop that for a second and go to here. And there we can see here, well, we're still southwest at this point here. We can go forward here and I'll show you those heights coming around to a more southerly direction as we go forward here. What I want to show you here with this one still picture, when we get to it here, this one here, this is 6Z. This is 1 a.m. on the model. We're a little bit past that right now. It's about 2:30. But I want you to notice here, look at the orientation of this trough here. It's basically right now, it's neutral on the model here. You can see here's the trough axis right in here. Pretty much a neutral trough. Now, the reason I'm showing you that is I want to show you now the water vapor imagery, and we'll come back to that. And here's our water vapor loop, valid pretty much right. Let's see. Let's go up here to the latest we can get. Okay, this is 615Z. This is, again, a little earlier than now. But look at the orientation of the trough. Look at this. It's already negative. It's already negative on the water vapor loop. So, you know, this system is strengthening ahead of what the models had said. And we'll show it loop here, and you can see that the trough switching from neutral to negative. You can see this swinging around here, and as a result, watch what's happening with these clouds. Okay, back edge of the clouds here. We'll stop this. Okay, here's our back edge of the clouds, or at least of the deep moisture. In here, there it is there. Okay, now let's go back and we'll start this loop again. Well, we'll do it forward manually here so we can watch it. Watch the clouds. See them starting the back here? See them starting the back? We'll see where they are now. They're back here. We're starting to pull them back a little bit. We'll go back here. We'll turn that off. You can see those clouds, the deeper moisture starting to back a little bit more to the north and west as the trough is going negative as it's coming in. And you can see now we're starting to get some pretty nice deep moisture coming across in there. So that's going to be a main factor with this system. Here's where our low pressure is right now, and right now it's stronger, and it's a little bit further north and west than the models had shown. This was supposed to be around 1012, 1010, somewhere back in here. I'm sorry, a little bit north and east, actually, I should say, not north and west, little slightly north, but it's a stronger low, and we're getting a stronger gradient already up in here than the models had shown. So this is definitely a deepening system, and it will continue to do so. A couple of terms I'm sure you've seen thrown around and heard talked about have been evaporational cooling and dynamic cooling, and what roles those might play in whether or not some of the more eastern regions of the forecast end up getting rain or snow. I'm just going to give you a real quick, brief synopsis of what these things are. Evaporative cooling is exactly what it sounds like. It's cooling as a result of evaporation. What's going to happen is, if that happens, is you're going to have warmer air up along the coastal regions up towards 95, because as the storm is deepening, look at the way the winds are coming. Okay, you remember there's counterclockwise flow around low pressure. So here's your low pressure, counterclockwise flow, and look what's happening. You're getting water coming off the ocean. And the ocean water temperatures, for the most part, along the eastern seaboard up in here, are well above normal, well above what they normally are for this time of year. So there's a lot of warmth to be pulled in to this storm. However, what happens is with evaporational cooling is as snow is falling into that warm air, some of it is melting, some of it is evaporating. And what happens when something evaporates is it's basically stealing heat, stealing energy from the surrounding atmosphere. That's the simplest way I can put it. So as it's taking the heat out of the atmosphere is losing heat and it's cooling. And so you're cooling the column due to that evaporational cooling. So while maybe when you're starting out, when precipitation starts, maybe it's going to be 40, 42 degrees, 39, something like that, starts to rain in the thing. But up above, you have snow falling into it and evaporating. Some raindrops as well will be evaporating and cooling it, and you'll start to see snow mix in, and as it continues to cool, you see a change of snow. That's a possibility that can happen. Dynamic cooling is, when you think of something dynamic, it has energy, it has a lot of oomph to it, and again, that's the process of this low pressure system is going to be deepening very rapidly as it's coming up. That's going to be producing a lot of lift, a lot of energy. As the air is lifting, the air is cooling as well. Lifting is a cooling mechanism. Then you get a lot of precipitation falling through that cooler air, pulling that cooler air dynamically down to the ground. And that's what basically dynamic cooling is. You can also get dynamic cooling from a strong piece of upper level energy coming across, creating a lot of lift, creating that dynamic lift, and then in turn, the precipitation pulling the cool air down to the surface. That's a very basic explanation of it, but I just wanted to let you know what the general concept is when you hear those terms of dynamic and evaporational cooling. So that's what that is, and pretty much what I'm thinking for this storm is here. I'm calling it a snow stuffed Thanksgiving. We're going to see, still think our heaviest snow amounts are across parts of the Lehigh Valley up through northeastern Pennsylvania, and then our heaviest amounts across extreme northeastern Pennsylvania and up into western Massachusetts and extreme southeastern Vermont and southern New Hampshire. We'll have the jackpot, I think around about 10 to 14 inches. But let me just say there are going to be zones of convective activity. There will be a convective band, a deformation band that's going to form. And somewhere, I think the most likely area is probably somewhere in here. And there are going to be surprises with that. So, don't be surprised if, the majority of this area has 4 to 6, but there's a couple of spots that get some thunder snow, and you're seeing, 7, 8, 9, 10 inches of snow out of this. So that's certainly not out of the question. Some areas up in here, 6 to 10. Don't be surprised if there's some areas over a foot with some convective snowfall. I think that some areas will have that. But I think in general, as far as capturing the spirit of the storm, I think this is going to do it here. Again, if that dynamic cooling, that evaporational cooling is stronger, it's possible there's more snow in here. It's possible there's some snow in here. I highly doubt that. I think this is too close to the warm water down in here, but it's possible. Certainly this area, it's possible to see more snow, or it's possible the dynamic cooling, the evaporational cooling is not enough to overcome the strong gradient, bringing the warm air off the ocean, and this gets pushed back. That's possible too. But, it's a very tricky storm. It's a very nowcast storm. Be watching how things are evolving. But as I showed you with that water vapor loop, we're already evolving faster and stronger than the models had shown. So that may be a good sign for some good surprises for some people. All right, that will do it. We'll see how this storm plays out. Hope you all have a great night. And if we don't do another video, have a very happy Thanksgiving.